All right, this is AP BC Calculus. We are doing Unit 9, Section 3. This is a BC only topic and a BC only unit. So let's do arc length in parametric. So let's do a quick review of the slide from 8.13 where we learned arc length. So we learned this arc length formula in Unit 8, Section 13, and that it comes basically from Pythagorean theorem and integration, right? So now, basically, when we use this formula in Unit 8, Section 13, we factored out either a dx squared or a dy squared, depending on what we wanted to integrate with respect to. Well, the only difference here is that we're going to make everything in terms of t. So I'm going to multiply the entire right-hand side of this equation by dt over dt, which is the same as dt over the square root of dt squared. So I can send that dt squared inside the root on the bottom. And you'll notice that what I end up getting is that my arc length, or my tiny slice of arc length rather, is dx dt quantity squared plus dy dt quantity squared, or if you want to write it this way, x prime of t quantity squared plus y prime of t quantity squared, all inside that root, right? To find the arc length from a to b, right, from t is a to t is b, we just integrate that formula. So it looks like this, right? So it's the same basic formula that we've seen, except instead of being, so in function mode, right, when we were talking about functions, right, we got that arc length was the integral from a to b of either 1 plus dy dx quantity squared with respect to x, or, right, so that was with regards to x, right, so this is in terms of x, or the same thing, right, but let's say from c to d, if we were talking in terms of y, of 1 plus dx over dy quantity squared with respect to y. Same idea. Well, here the difference is that everything's differentiated with respect to t. That's it. So you'll generally see three types of arc length problems in parametric, okay? Set up but don't integrate, where they just want the expression for the arc length, but they don't want you to integrate. A calculator problem where you're actually allowed to integrate, or a non-calculator problem where you're asked to integrate and find the arc length, but they're very rare because you have to choose the functions very carefully as the person constructing the problem to make it doable by hand. So really, you're going to see these two much more often than you're going to see a non-calculator find the arc length problem. So let's go ahead and walk through some examples. So non-calculator set up but do not integrate an expression to find the arc length of the curve from t is 2 to t is 8. So I need two things. I need x prime of t, right? So x prime of t is going to be the derivative of cosine of 3t, which is going to be a negative sine of 3t times the 3 from the inside, right, because of the chain rule. And I need a y prime of t, which is going to be a 3t squared plus 5. So my arc length, s, is going to be the integral from 2 to 8 of the square root of negative 3 sine of 3t quantity squared plus 3t squared plus 5 quantity squared with respect to t. Don't FOIL, don't clean up those things. This is the answer, that's all they want, right? So it's really about memorizing that we're looking for x prime of t quantity squared and y prime of t quantity squared inside the root. We're integrating between the two t values. They're not going to ask you to clean it up. If it's multiple choice and that answer doesn't appear, well, then you might have to look at your answer and see which answer matches your answer if you clean it up a little. But if this is a free response, this is all they're going to want. And even on multiple choice, this is usually all they want. All right, so let's go ahead and do the same thing. We're going to find an integral expression, right, for the arc length of this curve from negative 1 to 5, right? So again, I need two things. I need x prime of t, which is going to be a 2 cosine of 2t. I need y prime of t, which is going to be a 4e to the 4t, right? So then my arc length is going to be the integral from negative 1 to 5 of the square root of 2 cosine of 2t quantity squared plus 4e to the 4t quantity squared with respect to t. That's it. Don't clean it up unless you are required to do so because you're asked to do something else in the problem, right? If you're asked to set up the expression, just set it up in the most basic of terms. All right, now this time I'm asked to find the arc length, but I have a calculator to help me, right? So remember, my calculator can't differentiate equations for me, so I'm still going to have to do the differentiating. So I'm still going to have to get that this is a 10t, right? And I'm still going to have to get that this y prime of t is a 2t plus 4, right? So the integral that I want is the integral from 0 to 2 of the square root of 10t quantity squared plus 2t plus 4 quantity squared with respect to t, right? All right, so now we just need to actually find the value in our calculator. And there's a couple different ways to do this. So one way to do it is if you're in parametric mode. So let's go ahead and go to parametric mode and obviously make sure you're in radians because that's super important, right? So I can go ahead and put in what these two derivative values are, right? I can put in that x prime is a 10 t, right? And I can put in that my y prime is a 2t plus 4, right? And then I can quit out. And so then I can go to math 9, right? Math 9, which is function integrate, and I can integrate the square root of, and then inside my square root, I want vars over to y vars, and then I pick parametric. I want x1, which was what I called, so I called this thing, right? In my calculator, I called this x1t, and I called this y1t, right? So I did like this piece right here, not the original functions, right? So plus vars over to y vars. I can pick parametric, and I want y1t, which is 2, right, squared. Close that. That closes the square root, right, comma, with respect to t from 0 to 2. And you can also do this if you're in function mode by just typing in literally this entire equation, but with x's, and that's fine, but I think this is not a terrible idea, especially if you're going to have multiple arc length problems, because then you can basically just change what y1 and y2 are, what y1 and x1 are. All right, and there we go. So I get that the arc length of this thing, right? So my job was to come up with this, right? This is me. These two things are me in person, and then this piece is the calculator, right? Nobody expects you to find most arc length problems by hand, and if they do, it's going to be a really specific arc length problem. It's going to be something where you can integrate by hand, but most of the time they won't be. All right, so let's go ahead and do P2, same idea. So the part that I have to do, I have to find x prime is a negative 2t. I have to find that y prime is a 12t squared plus 8, right? I have to write that the integral should be the integral from 1 to 3 of the square root of x prime squared plus y prime squared with respect to t, and then I let my calculator do the heavy lifting. Now notice, I'm kind of lazy. I already have that typed in as function integrate, right? So if I go back to my y equals, I can just go ahead and change my x and y values to match this problem, and then I can kind of plagiarize myself. So t squared plus 8, right? And then I can use my own existing work by hitting second enter. I already have the entire correct formula. I just need to change my bounds to be 1 to 3. And again, I could type it away from scratch, but why? Because that would be silly. And I get 120.275 or 6, depending on if you round or truncate. So again, this is you, right? And this is your calculator, but you have to have all of it, right? So that's you and your calculator, but you have to have all of it. All right. So let's go ahead and do another example. So this time we're actually given x prime and y prime. So we don't even have to do the step where we find that, right? So we're asked to find the arc length from 1 to 2. So I'm going to have to write that the arc length is the integral from 1 to 2 of my x prime, which is the 6.1 cosine of t squared, plus my y prime, which is the 4t over t minus 3 squared with respect to t, right? So this part's me. And then I'm going to use my calculator to find the answer, right? So when I go to type this in, I don't have to differentiate. I already have x prime and y prime, so I'm going to put this guy in as my x1t and this guy in as my y1t, right? So make sure you're in radian mode. I did just check, and I am. So cosine of, make sure the t is squared, not the cosine, right? So 6.1 cosine of the quantity t squared, and then a 4t divided by, because the 4t is a monomial and it's on top, I don't need parentheses. If you're ever anxious about this, just put your entire numerator and your entire denominator in parentheses. The denominator does need parentheses here because otherwise it would divide by t and then subtract the quantity 3 from the whole thing. All right, so we're here, right? I quit out of this. I go to math 9 and I pick, that's my function integrate. I want the square root of vars over to y vars and pick parametric. So that's x1t, which is my x prime, right? Plus vars over to y vars parametric, and I want y1t squared. Close the square root, comma, with respect to t from, I believe it's 1 to 2 in this situation. And there we have it. So I get that this is a 5.720 or 721, depending on if you round or truncate. So again, I have to communicate this understanding, but then type, calculator's done. Oh, do not use calculator notation in this. Don't call this x1t in your formula. It has to be the actual math notation, not the syntax. All right. So this one's the same gist, right? Same problem, except from 1 to 3 and a different x prime and a different y prime. So again, the part that's u is you need to set up the integral from 1 to 3 of the square root of x prime of t quantity squared plus y prime of t, which was given to you, quantity squared, with respect to t. That's your job. And then, so that's you, right? This part is what you have to communicate for understanding. And then this part is your calculator, right? So you have to be comfortable using it. So really, I already have the format typed in. I just need to go back and change what my two values are and then change the bounds. So I have 1.2t and then an e to the 2t. And that looks right. And then I have a 5.8 divided by, in parentheses, a t squared plus 1. Double check that everybody looks good. Cool. I quit out of that, and when I hit second enter, everything's right except the bounds are 1 to 3, right? And I hit enter. So I get a 603.024 or 5, depending on if you round or truncate. All right. So non-calculator again, we're going to find the arc length of the given curve from 1 to 4. So I need to find x prime of t, right? So x prime of t is going to be e to the t minus 1. I need to find y prime of t. Well, that's going to be a 4e to the t over 2 all times a half. So I'm pretty sure that that's a 2e to the t over 2. Cool. So then my arc length should be the integral. Now notice, it asks you to find the arc length, not just the expression, which means this has to be one I'm able to integrate, but it's going to be a little ugly sometimes. So I have to have my x prime quantity squared, which we'll deal with in a sec, right, plus my y prime quantity squared, right, with respect to t. So when I FOIL this guy out, I'm going to get an e to the 2t minus an e to the t minus another e to the t plus a 1. And when I distribute this squared, I'm going to get plus 4e to the t. So after, so that's what this whole inside ends up looking like. So I'm just going to kind of call this work, right? That seems to me to be an e to the 2t plus a 2e to the t plus a 1. This is a perfect square trinomial, right? Because if you called e to the t you'd have u squared plus 2u plus 1. This is a u plus 1 quantity squared. And that's really what this usually boils down to, is that this is a perfect square inside a square root. And that's usually the trick with these, is that these two cancel. I know this is a positive quantity, so I don't need the absolute value because e to the t is already positive, and then I'm adding 1 to it. So this ends up being the integral from 1 to 4 of just e to the t plus 1, which I can do by hand. So again, that's usually the trick with these arc length ones, right? So this integrates to e to the t plus t from 1 to 4. So I'm going to get that my answer is e to the 4th plus 4 minus e to the 1st plus 1. And so my final answer is going to be e to the 4th, pretty much I'm going to say plus e to the 1st plus 3. I think that's fine because it would be a plus 4. Oh, sorry, minus e to the 1st, my bad. Careful. Minus e to the 1st and minus a 1. So minus e to the 1st plus 3, and that's my answer, right? So that's my exact answer for the arc length. So really, this is the trick it almost always boils down to, is that this, when you clean up the stuff inside the square root, it's usually a perfect square. It has to be very carefully designed for it to work. All right, so let's do one more of those. Again, these are fairly rare because you really have to put a lot of effort into making them work. So, so I need to find x prime of t, right, which is going to be a 6t. And I need to find y prime of t, which is going to be a negative 6t squared. And that means that my integral for my arc length is going to be the integral from 1 to 4 of the square root of 6t quantity squared minus, plus a negative 6t quantity, 6t squared, quantity squared dt, right? When I clean this up, this is a 36t squared, and this is a plus 36t to the 4th, right? Because it's t squared squared. So I'm pretty sure that I can, so we're just going to call this work for a sec, right? I'm just going to say, hey, I'm doing a little bit of work here. I'm pretty sure that I can take out a 36t squared from this and be left with a 1 plus t squared, right? Oh, this is still pretty ugly. Yeah, it's still pretty ugly. Oh, no, it's not. Never mind. I take it back. It's totally fine. All right. Sorry, sometimes my brain has its moments. So this is a 36t squared. And so remember what I said in the last one where I said very, very frequently you're going to find that this is a perfect square, and this one's not, and that's what stopped me for a sec. But the trick here, right, this piece has to be positive in the window from 1 to 4, right, because you're looking at the window from 1 to 4. So essentially I can make this come out of the root as a 6t, right? So now what I'm looking at is a simple u sub problem. This is simple u sub, where my u would be 1 plus t squared and my du would be a 2t dt. So what's going to happen, and I'm just going to, let's switch colors for a second, do a little bit of work on that u sub. So here's some u sub without bounds, okay? So without the bounds, right, the u is the 1 plus t squared, the du is a 2t dt, so my dt. So my du over 2t is my dt. So I'm going to get 6t root u over 2t dt. I'm going to get that this is a 3 times the square root of u, and it needs to be, du, and it needs to be integrated, right? So when we integrate a 3u to the 1/2 du, right, we up the power to 3/2, and then we multiply by 2/3. So this is going to be a 2u to the 3/2, right? That's what we want. So once I know that, I say, okay, cool, it's not really a u, right? It's a 1 plus t squared. And again, this is not an easy problem. You're not going to see many of these, but it does happen. So it does happen. So t squared to the 3/2, right? So that's what this is going to integrate to. So now let's go back up. So this is all my work only without bounds, right? So now let's go back up and deal with the bounds in red. So this is going to be a 2, 1 plus t squared to the 3/2 evaluated from 1 to 4. So we're going to end up getting that this is a 2 times, when I plug in 4, I'm going to get 17 to the 3/2. And I know that's not awesome, but that is what it is. It's the best we've got. It's not fun, but it is what it is. Minus a 2, and when I plug in a 1, I get 2 to the 3/2. And that's really your answer. Like, that's the best you've got. You can't really clean this up much. You can factor out a 2 if you want, but that's your answer, right? And you could certainly check that on a calculator and see if you get the same irrational answer, but that's the best you're going to get. Sometimes they turn out nicer. This one did not, in particular, turn out super nice. So that's what we have. All right, and that's it for this video.